Well, it turns out that Steve worked at Amazon at an interesting time. For about 6 years, around 2002, when Amazon transformed itself from being a company that just sold books to selling all the products we know today, but more importantly, transforming themselves into a web services company. It's a web services company that today in public cloud revenue, Microsoft and Google are still trying to catch up to. It's a web services company that transformed the finances of Amazon. It's a web services company that accounted for almost 100% of Amazon's operating income in the last year. And also, it's a web services company that transformed the finances of Jeff Bezos himself. And Steve traced this transformation of Amazon to a memo, a mandate that Jeff Bezos sent out in 2002. And that memo began kind of like this. It said, all teams from this point forward in the company will expose their data and their functionality through something he called service interfaces. He said all teams must communicate through these service interfaces. He said there will be no other form of inter-process communication. You can't directly read another team's database, no direct linking, no backdoors whatsoever. And he said, I don't care what protocol you use. You can use web protocols, World Wide Web protocols, or other protocols. He said, but most importantly, service interfaces will be externalizable, meaning that software developers outside of Amazon should be able to use them just as easily and safely as people inside the company, no exceptions. And then he finished this memo by saying, anyone who doesn't do this will be fired. Thank you. Have a nice day. Well, you can imagine how this might hit like a bombshell in the company if you worked in human resources and you were about to hire someone. Well, now you might not hire them. You probably want to hire an IT person because you need to build a service interface if anyone's going to read that database. But of course, this transformed all the products and services that Amazon produced going forward. So for example, when Amazon created instant video for people to watch movies, they externalized those tools and software developers started using them at other companies, at companies like Netflix. At peak times in North America, almost 40% of the internet traffic is people watching movies from Netflix. Everything up to the play button is coordinated on Amazon's servers. Amazon coordinates the delivery of more videos by competitors than they actually stream themselves. The same thing goes for their image storage. They needed pictures of their products, so they externalized these tools as well, and software developers at other companies started using them. At companies like Pinterest, 50 billion pins of pictures on 1 billion different boards, all of them coordinated on Amazon's infrastructure, showing more products that could be sold than Amazon themselves even cares. Of course, Amazon had to learn a variety of security lessons because these service interfaces could be attacked by hackers because they were external. And they had to learn so many security lessons that even today, the United States government's Central Intelligence Agency stores some of their data on Amazon servers because it's safer from the government's. So, of course, these service interfaces today, we call them application programming interfaces, or APIs. And companies around the world have perfected and polished the process of taking what began as internal tools and then turning them into external businesses. This is just a tiny short list of tools that began inside Google that then became external businesses for Google. For centuries, we have created companies that were very good at talking to consumers, to people. And yet, today's generation of companies are those companies that are designed to talk to computers through these APIs, these application programming interfaces. And you can track the rise of the API economy through sites like Programmable.com. This is a graph we did counting the number of APIs out there. And of course, it looks like every graph you've seen today. It's exponential. Over 19,000 different APIs by companies today. And you can search in your own field and see what other companies' APIs might be. So if you search for energy, you'll see there's over 100 APIs. You search on Bitcoin, there are over 300 APIs. Unless you think that there may be some product that is too niche to actually have an API, even beer itself has 11 APIs. And there's a hunger for these APIs. It turns out that Domino's Pizza did not have an API, so what did hackers do? They went in, they reverse engineered the website, they posted the code onto a public site called GitHub so other programmers could use it. And what did programmers use it to do? They used it to create little buttons that they could put on their desk so that they could just pound it and instantly order a pizza. They called it PayPal, kind of like PayPal. And you may have seen Google acquired a software company called Apigee for over $500 million. And what does Apigee do? It helps companies build APIs and helps them monetize those APIs as well. It's for this reason some people are now saying that every modern company today will either be an API or you will be paying a bigger one that is. And of course, this means companies have also started to ask the question, what is, I'll just wait for pictures. Pictures are good. Feel free, that's great. What are the APIs that will own our industry? What APIs should we be building for our particular field? Well, of course, one approach as companies start to think about that you can take is to take Amazon's approach, where it was the tools that they used to build their service that when released to competitors became a bigger business than the service those tools were used to build to begin with. For this reason, companies have started to ask the question, what are the data tools we used to build our products and services, and what if we were to take those and release them to competitors? How could those build a bigger business than the original product or service we built to begin with? Well, as companies start to think about their APIs and how to build them, one of the best pieces of advice I've heard is from Tim O'Reilly. He's the CEO of one of the largest technical publishers in the world. And Tim said, I see a lot of companies. He said, I review a lot of companies, and he said, one of the smartest things I see companies doing today is doing something he calls enriching their base layers. And the example he gave is of Google Street View. How many people are familiar with Google Street View? Where you zoom in and you can look around and you can see on the maps. Well, remember when that first came out, what people said? People said, oh, Google's going to put advertising on real estate. That's what's coming. And the answer was, well, really? Maybe, right? It's been a decade, but not yet. So what are they doing with the Street View data? Well, it turns out, as the Street View cars drive, they have machine intelligence in them that automatically picks up the names of the streets. And they also automatically pick up the names of the business. And so as a result, creating a base layer of all the street names and a base layer of all the business names. And this means, of course, that when you go to almost any country today, they can create digital maps with the street names and the business names on it. They're leveraging those base layers to create that product. But of course, they're using it for something even more. So recently, a Google engineer was being interviewed on the self-driving car project. And they asked him, how is it that your self-driving cars are so successful? Because at that time, the self-driving cars had driven like 2 million miles. I think it's over 6 million now. And the Google engineer said, it turns out it's a lot easier to know the state of a stoplight or a stop sign if you already know where to look. And what he said was that they were using the Street View data and pre-computing where all the stoplights were. So as the self-driving car drove around, it's like your human memory. It already remembered where the lights were. It already knew. And so if someone wanted to build a self-driving car as good as Google's, they would have to create this base layer as well. And you might wonder how valuable that base layer is, like how much it might cost to build it. Well, it turns out we actually know the answer because Uber hired away Google's former map person. And how much money did they set aside for that to build that base layer? $500 million. And so Google has been very good about enriching their base layers. So for example, remember Google released Gmail so that they had all of our text from email so they could create natural language processing technology. Then they created Google Voice so they could capture a bunch of voice data so they could create interactive voice response systems. And then of course they combined those two so that they could create an interface to create the Google Home, which is like the Amazon Alexa. But of course you want your Google Home to be able to answer questions, and Google's been very good about creating one of the biggest base layers of all, and that's by indexing the World Wide Web. And as they index more and more of the World Wide Web as a base layer, this makes their Google Home get better and better and better. And of course, just those 3 base layers alone, if we were to brainstorm for a little while, we could probably think of many other sort of products and services that we could build just having that data and those sort of interfaces. So it's for this reason that companies have now started to ask the question, what are our company's base layers that we should be enriching? What are the base layers that we should be building up so that we can build new value, new products, new services? Of course, one place when companies start to try to build these base layers, one place they can look is to look to their data exhaust. And perhaps my favorite example of data exhaust is the wearables world. So we've all seen the sort of rise of the wearables world, things like Fitbit, right? And what do they track? They track how many steps you take, they might track your location, and yet, what is something that almost everyone already carries that already does that? Any answers? Our phone, right? Our phone has a GPS device, it has a pedometer inside of it, and of course a company realized this, a company called Moves. They created an app, and the app does almost everything that Fitbit does, but it does it simply using the data exhaust coming off your phone. This was ultimately acquired by Facebook, and there are now companies and organizations all around the world that are leveraging data exhaust to create new value. I'll just give you one example. It turns out that 1 out of every 3 fish that we eat is fished illegally. And yet, the challenge is that there are 200,000 ships on the ocean, and 1 out of 6 of those, or about 35,000 of those, are fishing boats. And in order to figure out whether a boat is just shipping or whether it's fishing, analysts have to sit down and watch the boats for hours. The signals that are given off, the GPS signals that tell what direction and how fast they're headed to prevent collisions at night or collisions during fog. And they have to watch and see if these boats have a long liner pattern where they're throwing lines, a trawler pattern, or a circular purse seine pattern like they're throwing nets. And this takes them hours and hours, and yet there's 35,000 boats, so they can't keep up. Well, recently the Leonardo DiCaprio Foundation donated money to Global Fishing Watch and trained up 3 machine learning, machine intelligence algorithms to recognize these 3 patterns, long liner, trawler, or purse seine pattern. And then they turned it on. And today, if you go to globalfishingwatch.org, you can see in real time where all those fishing boats are fishing currently. But notice that there are also red boxes. These are areas where there should be no fishing going on whatsoever. So when they turned on the system, they went and they looked at the Phoenix Islands. It's a World Heritage Site. It's a protected site. There should be no fishing going on whatsoever. And when they looked, this is what they saw. This was all the fishing. So they went to the president of the Kiribati Republic, who's responsible for this area, and they have one fishing boat to patrol 157,000 square miles. One patrol boat. And the president of the Kiribati Republic said, don't worry, we'll take care of this. So this was November, this was December, this was January, and this was February. How did they do it with just this one fishing boat, with this one patrol boat? Well, the answer is that they could turn on the system and they could see these boats moving, and they could see this sort of purse seine pattern, and then there's like a trawler pattern, and here's the Phoenix Islands, and then they could see the boat travel, and they see the boat travel through, and oh, what's this? So they went to the ship's boat captain and they said, were you fishing in the Phoenix Islands? The ship's boat captain said, no, I wasn't fishing. They said, what was this? And he said, oh, I was fishing. And they fined him $2 million. And so, little by little, this is how they tracked down and stopped all the illegal fishing. But what's perhaps most remarkable is that all of this was done using the data exhaust that's been coming off these boats for years and years. And it's for this reason that companies, it turns out that this data exhaust is building up in a variety of different companies. You may have seen Forrester did a study, and they found that 63% of the data on average in a company is unanalyzed. It is what they call like dark matter, they call it dark data. And companies are now starting to realize that this dark data has value. How many people are familiar with iRobot, the robot that sweeps your home? So few people out there. So it's a robot that sweeps your home, right? But it turns out as it sweeps your home, it also creates a map of your home. And so now iRobot is sitting on more digital maps of more people's homes than almost any company anywhere. And as we move into a world of augmented and virtual reality, they're suddenly realizing that this digital maps, this data exhaust that's coming off the robots actually has value. And so they're looking to sell it to companies like Apple. Just to put an exclamation mark on that point, you may have seen Apple just recently acquired an AI startup focused on dark data for several $100 million. Nobody knows what Apple's doing in the dark data space, but we're all sort of waiting and watching to see what that might be. So it's for this reason that companies are now asking, how can we use our dark data? What is our dark data? Where is our dark data? And also, what is our data exhaust? Where do we find it and how might we use it? And is there other companies with data exhaust that we might leverage to build new value? So remember when Amazon showed the value of the long tail, basically selling just small numbers of many, many different products, and yet they were able to grow their business by estimates 30 or 40% by doing this? Well, it turns out you can apply long tail thinking also to your data approaches. And I'll just give you an example. If we were to take a data-centric view of LinkedIn, so just think of LinkedIn purely from a data point of view. What is LinkedIn from a data point of view? What would we call it?
Social network.
Right here, Ben. It's a network, right? It's a social graph. It's a series of pointers, who's connected to whom. And yet, what happens when you click on LinkedIn to connect with someone? What do they say? Only invite people you know well. So if there was this one person, maybe at this conference, that one person that you met one time, it would be good for you to be connected to them. They are saying, no, don't connect. Leave them behind. That is essentially like chopping off the long tail of their core data value, right? Their social graph. And some people believe that is just leaving data gold on the table. And you might wonder, well, how valuable is that long tail? Well, if you compare LinkedIn to a company like Facebook, Facebook has 4 times as many users, and yet they're able to translate that to a 14x increased market cap. Instead of $25 billion, it's a $360 billion market cap. And it's for this reason that when Microsoft recently acquired LinkedIn, Many people thought one of the reasons is that they just saw how much data gold was just being left on the table. And it's for this reason that companies have tried to look at their businesses from a data-centric perspective and ask the question, are we chopping off the long tail of our core data value in our companies? So let's say now in your companies you've solved this. You are now collecting your data exhaust, you're collecting your dark data. How do you make sure that as new data comes in, that you have people in your organization that are able to translate this and turn that data into value? How do you do that? You may have seen that MIT did a study. 40% of companies out there are having trouble finding data scientists. So if you're having trouble, you are not alone. And you may have seen McKinsey did a study. They found there's a shortage just in the US alone of 1.5 million managers for data science projects. So there's a shortage of managers for these projects as well. Well, so this is a picture of an office from the 1950s. And someone once said that if you were to combine what all the output of these people, what they were creating, that it is actually equivalent to a single cell in an Excel spreadsheet. That's how much computation is here. And yet, if you were to take this picture today in a company, what would all these people be doing? Many of them are working in Excel, right? And for many companies, Excel, they've now started to look at Excel as a weed. It's grown across the organization. Data is scattered in these Excel spreadsheets all across the organization. And people have now started to ask the question, how do we disrupt Excel? What's the way that we can take all this manual work that we're doing in Excel and automate that? Of course, my favorite example of a company that's done that is Netflix. And Netflix came to the realization that there are people all over in companies that have learned programming languages, and yet very few of us use it on a daily basis. And there's a whole new generation of people coming up through who are even more comfortable and have had more classes. And so they decided that they wanted to spread and harvest data literacy across the entire organization. And so one of the ways that they did that was to use a technology called Jupyter Notebooks. And what Jupyter Notebooks allow you to do is it's kind of like if you were to give every single person in your company their own page that they could go and immediately just start programming. So you may have heard that the simplest program in the world is the Hello World program. So now if I type print Hello World and then I click run right on the page, you'll see it says Hello World. But most importantly, as complex as you possibly want to program, you can, almost all of it, you can put right into the browser. It supports over 100 different languages. So you heard Hod talk about languages like TensorFlow. You may have heard of other languages like R. You can write TensorFlow code right into the page. And so what happened in Netflix is individuals, employees across the organization started writing computer code for what they were doing in Excel. And so what they used to do manually in Excel was now done automatically in these browser pages, in these Jupyter Notebooks. And then sometimes part of their work came from someone else. So they would share that notebook with someone else, and they would add additional code. And that person would share it with another person, and they would add additional code. And pretty soon they created lots of automation for things they were doing manually before. And now, today, across Netflix, 30% of their employees are automating some of the work they used to do in Excel, now in Jupyter Notebooks. And this isn't just the data science people, right? This is sales, this is marketing, this is operations. They have added data literacy across their entire organization using this technology called Jupyter. And you might wonder, how long does it take to create these notebooks? I was at a conference a few months ago. To create 10,000 notebooks took us about 30 minutes using a technology called Docker and Jupyter Hub, which means you can assign this to the smallest part of your IT organization and actually expect them to be able to get results. And as a result, we're now seeing Jupyter Notebooks across companies all around the world, and it is one of the primary ways in which computer programming is now taught, because you can just go in and start programming without having to install software. And it's for this reason companies are asking the question, what data should we make available across our organization for these Jupyter Notebooks so that we can harvest innovation from everywhere? So let's say you've done that. Let's say you've now deployed Jupyter Notebooks across your organization. You are capturing your data exhaust. You're capturing your dark data. How do you make sure that as new data comes in, that you're able to use it, that you're able to add it and get value from it? Well, how many times have you done that? How many times have you been in an IT project where you notice that your knowledge increases so much so that at the end, when you look back, people say, you know, if we were to do that project again, I bet you we could do it in a third of the time, right? And yet, how do we make our decisions? We make almost all of our decisions up front, thinking that it will mitigate risk, right? But instead of mitigating a risk, what do we actually get? We actually get lock-in. How many times have you been in a project where 6 months in, someone says, oh, I have an idea, and then everybody looks at them and says, why did you have that idea 6 months ago? Now it's too late, right? We can't use that idea. We've already made these decisions. And so in a world that is unsure and exponential, it is to match our decision curve with our knowledge curve. And what that means is delaying every single decision that you can possibly delay. Delay it as long as you can until the last possible minute it actually has to be made. And in that way, you take advantage of new opportunities. You take advantage of your rising knowledge. We call this late binding. The second approach is to take zero cost of change design. It has an architectural cost. You have to choose it up front. But by choosing that, later, if people have ideas, it means that you're able to pivot and take advantage of those ideas. And as the world starts moving faster and faster, this type of design becomes more and more important. We often see this in landscape design, right? Where how many weeks do they spend deciding where the sidewalks go and where the people walk, right? On the smart college campuses today, what do? They put down all the sod. They let students walk wherever they want. Then they come in later and put the sidewalks where the students walked. And the result is pristine lawns. This is late binding. And you can see this in IT projects. How many times have you started an IT project, and what's the first question they always ask? What data standard are we going to use? We need to decide on the data standard. You can lock up a project for months, sometimes years, trying to decide on a data standard. You may have heard the phrase, the great thing about data standards is that there's just so many to choose from, right? And so in this case, if you take a late binding approach, your approach is to say, no, we're not deciding on a data standard. We're waiting until the last possible moment we can. We absolutely have to make the decision. And you still move the project forward. In fact, I'll argue, if you take a data-centric approach with late binding, if you create a data lake, and all that data lake knows how to store is numbers, text, and binary streams, you can store anything in that data lake. And later, when it's clear what standard you actually do need to use, then you can create a data pond and map that data into that pond and have it exactly the way you want. This is a lot like we build skyscrapers, right? We build the skyscraper, people move in while we're still building the other floors. This is just applying that same principle to your data structures. So let's say you do that. You're now late binding all of your data as it comes in. You have Jupyter Notebooks across your organization. You're capturing your dark data. You're capturing your data exhaust. how do you make sure that all this data that you're collecting just keeps getting better and better and better? Well, you may have heard that the most successful companies today are those that can create virtuous cycles, right? And my favorite example is probably a company like eBay, where, remember when eBay came out, the more products that were on eBay, well, the more customers that went to eBay. The more customers that eBay got, well, where do you put your product? Where the customers are. And pretty soon, that flywheel has spun so fast that virtually no one has been able to topple eBay. Its fate was essentially a natural monopoly. Although you may have seen Facebook recently announce that they're going to try to spin up a wheel with their 2 billion people, and everybody's wondering and watching to see if it actually works. This is how Peter Thiel, the co-founder of PayPal, invests. He looks for companies that their fate is a natural monopoly, as opposed to their fate being a commodity, where it's a race to the bottom on price, or where it's a race to brand yourself. And of course, there are companies all across Silicon Valley who are now trying to build these virtuous cycles. But it turns out you can apply these virtuous cycles to your data cycles as well. And my favorite example is probably Waze. How many people are familiar with Waze? GPS mapping, almost everyone. It's interesting, some countries it's less. So what was interesting about Waze when it came out? When Waze came out, if your street wasn't on the map, you could go in and add your street to the map. And if there was a construction area that it kept routing you through, you could go in and indicate that that was a construction area. And as a result, the more people that used Waze, the better the maps got. The better the maps got, the more people that used Waze. And pretty soon that flywheel was spinning so fast that this little company of 80 people in Israel was acquired by Google for over $1 billion. Because they were able to create a virtuous cycle in their data lifecycle. And it's for that reason that companies are now starting to ask the question, how do we build virtuous cycles into our data lifecycles so that our data keeps getting better and better and better? So let's assume that you've done that. You are now leveraging data, virtuous cycles on your data. You are late binding your data as it comes in. You have Jupyter notebooks across your organization. You're capturing your data exhaust, capturing your dark data. How do you make sure that your company is aligned strategically so that you can get value from all this data that you're collecting? Well, my favorite piece of advice or example is from Vito Koslam, the co-founder of Sun and the billionaire venture capitalist. And Vito said, I see a lot of companies. He said, I review hundreds, thousands of companies. And he said, one of the things he sees the smartest companies doing is replacing their roadmaps with something he calls base camps. He said the problem with roadmaps in our companies is that they assume success at every step, right? We're going to do this, then we're going to do this, then we're going to do this, and yet we live in an unsure and exponential world. He said some of the smartest companies instead take a base camp strategy. And he said in most cases, companies are trying to reach a summit, right? There's some sort of long-term goal, a 10 or 15-year plan they're trying to reach. And he said, with a base camp strategy, if you're going to climb Mount Everest, you choose your first base camp, and that's where you rest, gain energy, so that you can make the leap to the next base camp. Or if you're a company, it's a base camp where you rest, build up revenue, so that then you can make the leap to the next base camp. And the assumption is that whatever path you thought you were going to take might fail. And you may have to go down the mountain and go up a different way. And a base camp strategy assumes potential failure at every particular point instead of assuming success. Inside Microsoft, we used to call these technology trees, where if we had one technology, if we had one base layer, well, that base layer would allow us to create this particular API. And then that would open up these other possibilities. And this would create this other base layer, and then you would combine these, and this would create new services, new products. And you can see there are little black boxes where we failed, where that experiment failed, and we had to go back down the mountain and go up a different way. So vNode's advice is replace your roadmaps with a Basecamp strategy. It's kind of like Stephen Johnson's book, Where Good Ideas Come From, where he says we navigate the adjacent possibles. Evolution navigates the adjacent possibles. It's like walking through a mansion, right? You open the door, that door opens up new doors that you can open, new rooms. You can't teleport from one side of the mansion to the other. We navigate the adjacent possibles. And yet, the number of adjacent possibles, particularly in data, are emerging quickly. I'll just give you one. Geoanalytics. The number of pixels that are available from space are increasing exponentially. You may have seen this company, Orbital Insights. They are tracking over 1 million parking lot images from space, looking at these particular pixels. And yet, these pictures can be tracked even in companies that don't want to tell you what their retail traffic is. You may have seen in Saudi Arabia, they drilled down through the aquifers and pumped the water to the surface, and we were able to track their farm yields in the desert from space. You may have seen that even the world's oil inventory can be tracked. It turns out that the roofs on these storage tanks float so that there's no vapor over top of the oil. And the result is that it casts a shadow on these storage tanks that we can see from space. And so using Insights was actually able to catch China underestimating their oil supplies to drive up the price. And so we can track oil supplies even in countries that don't want to tell us what their oil supplies are. And as a result, new thoughts, new value are being invented and created all the time with this data from space, including tracking agricultural productivity, car density, building height, and even the Department of Defense of the United States just offered a prize, a contest for people to determine new data from these satellite pixels. And yet, there are hundreds of new satellites planned for launch, which means great things for you because the price of these pixels is dropping exponentially, and these will be APIs that your company can leverage. But of course, remember IBM? IBM started 100 years ago, and they started with scales. And they have had to reinvent themselves continually in order to over the last 100 years. And you may have seen just this year, Gina Rometty, the CEO of IBM, stood up and said that of $80 billion in revenue, almost 50% came from projects that they invented and services that they invented in just the last 3 years. In the last 3 years, they've created a $40 billion worth of company. And yet, just to give you an example of how they do that, you heard previous speakers talk about blockchain, which is the foundation of Ethereum and Bitcoin. Currently in IBM, they have over 500 blockchain projects going on. How many of those do you think are going to fail? Probably all of them, right? Almost all of them, right? But they just need 1 or 2 of those to actually be a hit. And that forms part of this billions. And so, how does a company keep up? Right? This is 500 blockchain experiments, and then there's deep learning experiments, and now there's pixels from space, and there's all this technology. How does your company possibly keep up with all this? Well, perhaps my favorite example is from Pinterest. So you might recall, Pinterest, people save pictures. And there's often something inside the picture that they want to save, like this lamp. And yet, if I'm going to search for this lamp, using text, wirely polygonal black metal lamp, notice how good text search does. It's not very good, right? So they decided, we want to do visual search. We want people to just draw a box around this. And we want to use deep learning. But they had no deep learning experts inside their company. So what do? They took 3 people from their search team, and they partnered with 2 undergrad students and 1 professor at Berkeley. And then they had them build this system. Well, this is me using the system, and I drag across the lamp, and notice how good the search is. Much better than text. And they rolled this out to the front page of Pinterest, and before long, almost 50% of the searches were done using this search tool that this little tiny team created. But what's more important, and perhaps more remarkable, is that this entire project, from beginning to end, 6 months long. Imagine if they had waited 3 years, 3.5 years, to hire someone who graduated from college. It would be too late. They would be 3 years behind. And so many people believe that this is the demise of the ivory tower model of hiring. We can no longer wait 4 years to hire people with certain degrees in these areas. In fact, many people believe that this is the dawn of the ivory bridges model. That every modern company will be partnering with undergrad students and master's students while they're getting their education in order to harvest these new technologies. And this will become more and more important as technology moves faster and faster exponentially. In fact, even in the Healthcare Innovation Lab inside Microsoft that I ran, we had 12 different slots, 3 months long, just for undergrads and masters and PhD students to rotate in and through. You may have heard Joy's Law. No matter who you are, most of the smartest people work for someone else. So how do you get those people to work for you, for your company, if they're everywhere else? How many people have heard of Kaggle.com? A few people out there? So Kaggle is the largest data science competition site in the world. There are 60,000 data scientists working there. And as a company, you can decide to run a contest. In contest, you choose a prize, $5,000 to the biggest prize I've seen is probably $3 million. And here's an example. State Farm Insurance wants to see if you can use their data to detect distracted drivers. And they created a prize, $65,000. And when you create a contest, in real time, you can watch and see what the score is and who's most successful. And at the end of the contest, your company gets the IP, and what do they get? The credit. But many companies, after the contest is finished, they go and look through who the winners were, and they offer them jobs. This is how they find great data scientists that have been proven on their particular technology. Many people ask, how much data do we need to run these contests, or just to do AI work in general? Do we need big data or small data? Of thousands and thousands of competitions, virtually every single competition has been won by scientists using data that would fit on a laptop, small data. So chances are, odds are, your company already has the data it needs to be able to start doing data science work. So what about the future? What's ahead? Well, recently we were in Central America with heads of companies. They own mines, they own retail shops, and they said one of the problems we face is that all of our companies are commoditizing. Our margins are diminishing. And they said, we view a future where all of our products and services, our companies, we will have to convert our retail shops and our energy companies into service companies. And the example we talked about is energy. So it turns out there's devices you can place in the home that track which devices you use. And yet, and you know, when you use them and how much, in order to save you energy bills. But I can't tell you how many times that I was in the emergency department when a patient would have fallen and broken her hip, like a grandmother. And it would be hours or days before someone discovers her. And yet, if we were to put one of these devices in the home, now, if grandma or mom doesn't turn on the coffee maker like she normally does, or doesn't turn on the oven like she normally does in the morning, or doesn't open the refrigerator like she normally does, now daughter gets a text. And daughter calls up mom and says, Mom, you didn't do any of these things. Is everything okay? And she says, oh, I went to Judy's, and everything's fine. What they realize is that people may begin to choose the energy company based on the service provided by that energy company. And so companies have now started to ask the question, what services can we build over our commoditizing industries in order to reestablish our margins? Well, the last thing I'll talk about is later today, you're going to hear a talk on augmented and virtual reality. And you're going to hear about something called Augmented Reality Kit. And it's a tool that's inside all of your phones, iOS phones today. And notice that you can place objects in virtual space, and or in real space. And notice that these virtual objects, when you move back, that you can still see them. And you can change them, and you can zoom in on them. And this, of course, has implications for education. But one of the other opportunities is, here we can place a measuring tape. This is in the next version of iOS. It'll be built into the phone. And so we can measure things. And notice we are now disrupting the measuring tape business, right? And yet, because it's virtual, we can we can measure things that we haven't been able to measure before. Think about it. This is a new form of data collection. This is creating a new way of creating new base layers that never existed before. And just to give you an example of how much this can accentuate data collection, notice here they're pinning the corners of the room. And what happens after they pin all the corners of the room? They click a button and it creates a floor plan of the house. Who's collecting those floor plans? It turns out Airbnb is, the home rental place. Pretty soon Airbnb will have more floor plans than almost any company out there. And this will be a new base layer on which they can create new value and new services. And of course, the technology is getting even more sophisticated. You may have seen Canvas. It's a device you can put on your iPad. And now, as you sweep your iPad around, you can collect a 3D point cloud. Think about it. This is another base layer, right? 3D point clouds of every room, every cave, every airport, every plane, every company. All of those we will have. Someone will own those tools, that data, and someone will build the tools for those as well. You may have seen the IKEA apps that allow you to place virtual objects into space. This is another base layer. Who will own all these 3D virtual objects? It won't just be furniture. It will be factory equipment and others. This is another type of base layer. And it doesn't have to be stationary things. This is someone who created a moving robot and placed it in their living room. It is a little bit creepy, but it's something that's possible. And so it will be animations as well. It may be animations for how to escape different rooms safely. But also instructions. This is another base layer that's emerging. Notice this is telling people, trying to teach someone how to take steps in a dance. And of course, it's not just one person, but it can teach someone else as well. So as you're listening to Jody's talk, I want you to think about it in terms of the new emerging base layers that become possible. This is 3D data about a world. We used to send spreadsheets back and forth. Now someone will create the data tools in order to create these visualizations. This is the world population. You can place this in your office and other places. And it doesn't have to fit inside an office, right? This is someone who created an entire house. You can see it outside. They're viewing it through an iPad. Someone will own this as a base layer as well. And you can go inside and actually look outside the windows to make sure that these particular buildings are placed where you want them to be. And this is someone who put a portal inside their work office. And of course, you can walk into the portal, take a look around, and look back out. And then as they turn back around, you can see all the people who are still at work for them. Of course, you might wonder how soon this technology will be available to be viewable. You may have seen Apple acquired a headset company for about $30 million. So it's expected that by 2019 or 2020, we'll have devices right on our faces to be able to see all this data, all these new base layers. And some company, maybe yours, will be building and owning these technologies. And through this, you get a glimpse of how the world's next largest company in your own field may have new foundations of data so that they don't have to have traditional assets that others have had. And the good thing is while you're doing that, it means that there are more adjacent possibles. While you're doing this, there are more adjacent possibles than at any time in human history. And of course, this means great things for the work you're doing today, and the impact that you'll have tomorrow. So thanks so much for your time and attention.
That's a lot to take in. One thing I'm really thankful to you, actually, my wife was complaining to me a couple of weeks ago. She said, whenever we make plans, at the last minute you come up with another possibility. And I can now say, darling, I'm a late binder. So thank you. You've given me a way out. Michael, one thing, this is a disruption workshop, so we talked just before about creating a bit of disruption, and so look, do you want to talk us through, because what we're going to do, rather than you sitting silently and brainstorming for yourself, we're going to disrupt now. So if you describe what we're going to do, and then I will be thinking about a route of how we do that.
Okay, yeah. So we're going to take 5 minutes, and